For the first mini project concerning Jeannie's ice cream shop, we chose the decorator pattern. This pattern lets you add new behaviors to a base or plain objects by placing these objects in certain wrappers that contain specific behaviors. For this project, we are going to use ice cream as the abstract object and then include toppings and flavors to decorate our abstract ice cream. Here, we start with our abstract class or base object as ice cream. We have another abstract class, abstract toppings, which extends our abstract ice cream class. Then we have our toppings, which all extend the abstract class, abstract topping. These toppings all have unique descriptions and costs, but as seen here, they override the cost and description method from the overall abstract class ice cream. This way, each topping is independent, yet all are categorized as toppings with the characteristics of a cost and description. We also use the open-close principle, a solid principle, as the abstract classes can be extended without needing to be modified. Then each individual class can be modified based on unique descriptions and costs without modifying the original class. The decorator pattern keeps the code relatively simple and easy to read, as each topping has a similar setup, but contains unique information. Our ice cream class is not responsible for holding all the information of different toppings and scoops of the ice cream. Instead, the ice cream class holds the properties all the toppings require and lets each individual topping class define its own properties. Using the decorator pattern, new toppings or flavors would be easy to implement by simply adding a new class which extends from abstract topping and overrides the cost and description with the new toppings values. In our main method, we can see the results of our code. First, we create a double scoop of ice cream and then characterize it as being vanilla with hot fudge and sprinkles. Then we print the description of the ice cream, which includes the cost. We have a second ice cream single scoop that is chocolate with caramel and whipped cream. The description of this is also printed exactly as expected, as we can see here. To ensure all of our code works properly, we have 4 test cases as well. Our first test case checks the ice cream without toppings has the correct price. This ensures toppings are not a requirement of buying ice cream. Our second test ensures our printing of plain ice cream is done correctly with no punctuation errors. Our third test checks duplicate toppings are allowed and the cost of duplicate toppings is counted for correctly. Our fourth test ensures as toppings are added, our prices are increasing correctly. Then we can check that all of these requirements pass, which they do. This concludes the requirements of our code. Now let's take a look at the design class diagram. In our design class diagram, the decorator pattern is easy to see. At the top, we have our overall abstract class, ice cream. Then on the left, we have our concrete component, 1 or 2 scoops, which extends from ice cream. On the right, we have the decorator component, toppings which extend ice cream. Under abstract topping, or extending from abstract topping, we have all of our decorators, caramel, whipped cream, hot fudge, and sprinkles, all the toppings which can be used to create unique ice creams, as well as vanilla or chocolate, our 2 flavors. Thanks for watching.